So we have learned how to install the tool, right? We have learned how to install the tool. Now we are going to see how to use it properly, right? I guess pay attention. So this is going to be more practical than ever. But you have ever used an Arduino before, right? So Masa, what course did you do first? Telecom. Okay, so as I said, the board is the Arduino Nano 33 BLE, right? So now when we when we think about the Arduino, as I said the last time, the Arduino is just used to control things around us, right? The Arduino has sensors and it has actuators. You guys know what the sensor is? You know what an actuator is? Huh? Sensors, actuators. You guys know what that is? What is an actuator? An example of an actuator. Masa. Huh? Okay, an example of a sensor. Then what? Sensors. Any sensors you know? You guys don't know any sensor. Sensors. Probably. Sensors. Masa. An example of a sensor. Yeah. So what is an actuator? You guys don't know what an actuator is. Huh? Yeah, the DC motor is an example. So what the Arduino does is that it takes a sensor, right? It senses what is on the sensor, and then it does something to an output. The output can be an actuator, like a DC motor. You guys know what a DC motor is? So probably it takes the sensor value and then it turns the motor on the actuator based on the sensor value. That's what the Arduino does. It's as simple as that, as I said the last time. So the Arduinos have they are no keyboard, they have no mouse, they have no screen, right? It's just the board. Like for the one I have, as I said the last time, this is what I'm going to be using. The Arduino Nano says, you see that there's no screen, there's no keyboard, there's no mouse. This is just it, right? And then it is capable of a lot of things. And then it has no operating system also. You know what an operating system is? If you say yes, sir, then I ask you what an operating system is, then you start to fumble. What is an operating system? Operating system. Uh-huh.
Set of instructions that allows, should I say, machine to work.
Yeah, probably. Yeah. So these Arduino boards have no operating system at all, right? So their purpose is just to sense a value and then do something to an actuator or an output, right? Understood? Now, but as you said, the operating system is like an interface between the user and the hardware. The hardware is just chips on the board, right? So the operating system serves as an interface so that it takes something from the user. Like you can design a software for it, right? And then the user does something with the software, and then the hardware can understand based on the operating system. So we have different types of operating system as you guys know. And then there are different types of boards. We have the Arduino Nano, the Uno. I think you guys have the Uno. Who has the Uno? Somebody said he has the Uno the last time. You have one. The Uno, right? You have the Uno, not the Nano, not this one. All right. So how many people? Only one person. The whole entire. Yeah, so but you can always use it, right? So we have the Uno Nano, and then we said that we can program this board using the Arduino what IDE, right? So and I showed you how to install the Arduino IDE on your computers. We even went through some examples, right? Right? And then, so this board actually is the Arduino Uno, and then this one is the Arduino Nano. Have you seen the differences? Okay. Now we have this is the general architecture of every microcontroller. But I mean, first of all, there are some terms. There are some terms you need to know, right? There's a term like microcontroller, right? There's a term like microprocessor, right? There's a term like a computing system, right? There's a term like embedded system. You guys must know all these differences. Do you know the differences? So the first term is let's take a computing system, right? So we have computing system, right? And then we have our second term is an embedded system. Embedded system, right? You guys must know the differences between a computing system and I think that the last time I made mention of something like that. The differences between a microcontroller and then a microprocessor. I think I made mention of that the last time. Did I do that? Microcontroller, microprocessor. Okay, but first of all, we have a computing system and an embedded system. What is the difference? Nobody knows the difference between an embedded system and a computing system. But but you guys know what your laptop is. You guys know what your desktop is, right? Your laptops, your desktops are computing systems, right? The computing system has a CPU within it. It has, I think I said this the last time, right? We have within this computer system, we have a CPU, we have memory, then we have input output, right? We have these three components within every computing system. Your desktop, your laptop, supercomputers, whatever, servers. That's the computing system. You have CPU, memory, I/O, and then all these units are separate. The CPU is separate from the memory is separate from the I/O. That's the computing system, right? What of an embedded system? Huh? So an embedded system has exactly the same things: CPU, memory, I/O. But the CPU, the memory, and the I/O are on a single chip. Are you getting the difference? So these are some kind of exam questions. So if I set the questions and then I say give me the difference between embedded system, computer system, and then you say I didn't teach you. There is video evidence. Understood? So the embedded system has exactly the same things: CPU, memory, I/O, but they are on a what? A single chip. For the computer system, they are separate, right? Now, what is an example of an embedded system? Your your aircon is an embedded system, right? Your smart fridge, if you have a smart fridge, is an embedded system, right? If you have a microwave, it's an embedded system. The embedded system do exactly one thing. It does only one thing. What does it do? It just blows in a cold air. That's all it does. Oh, no. The fan has no electronic, and it has no IC in it, so no. But you see that for the general computing system, you can use your computers for a lot of stuff. You can use you can have a range of softwares on it to do a lot of stuff for you. But for the embedded systems, it does only one thing. This fan only blows, right? Uh, your microwave does what? It does only one thing. It can't do anything else. So that is it. Yeah, yeah. So it does only one thing. So that is your main difference between your computer system and then your embedded system.
So
Yeah.
is a computer and embedded system involved?
Mhm. It will be an embedded system because the functionality within it is just limited. it can only do some form of some form of calculations, right? It can't do everything like how your CPU or your computer or desktop does it. And so, do you understand? So you have seen the differences between a computer system and an embedded system, right? Now let's look at microprocessors and then a microcontroller. Now, the CPUs within the I said the embedded system and the computer system have the same exact components, but the difference is that for the embedded system, it is on a single chip, while for the computer system, they are separate chips, right? Now, the CPU within this computer system and then the embedded system is the microcontroller. Just the CPU is a microcontroller. Understood? So it means that the computer system has both, the computer system and the embedded system both have a CPU. Understood? Understood? Now, the computer system, right? The heart of the computer system, everybody knows, is the CPU. So the heart of the computer system is the microprocessor, right? For the embedded system must have a micro what? Controller, right? The microcontroller has the CPU, memory, everything attached to it, just like what we have here, right? It has a CPU, it has memory, and then it has an interface for you to give it data, and then it has an interface for you to receive data. So this is a what? A micro what? A micro what? A micro what? Yeah, so this is a microcontroller. Now, this is the generic architecture of a microcontroller. What is inside this chip here? This is the general architecture. It must have, as I said, CPU. The first one, the CPU. It must have memory, and then it must have some kind of I/O input. If I say I/O, I mean input output, right? Now, uh, when we even talk about the internal memory of the microcontroller, we have kind of different types. We have the flash, we have the SRAM, we have the EEPROM. You guys know what each does. There are differences between a flash memory, SRAM memory, and then the EEPROM. You guys know that, right? You know that. So what is a flash? Flash memory. Huh? Hurry up, hurry up, hurry up, hurry up, hurry up. Flash memory. Now, but you guys have studied memory somewhere before, right? Some course like that. No, nothing. Have you guys heard about the word volatile before? What? Based on what? Yeah, yeah. So, have you guys heard of volatile before? And non-volatile? Huh? Right? So, there we have memories that are volatile, and then we have memories that are non-volatile, right? The volatile memory means what? Huh? It means what? Understood? It's just an English term. So, and then non-volatile means what? It retains the data, right? When there's no power. So, if you take the flash memory within your microcontroller, and then also the flash memory, your kind of pen drives and then hard drives are also made of flash memory. So if there's no power, the data is still there. So if you take a pen drive, right, and then you store something in it, and then you plug it, you see that you see the same data all the time, unless you actually erase it. So if there's no power, if there's power, the data is retained within a flash memory. So that's a flash memory. It retains data when there's no power, right? And then we have also SRAM. And then within this thing, right? As I said, you write your code on your PC, right? Using the Arduino IDE. You write your code, you transform your code into a code that your machine can understand, and then you upload your code onto the board, right? So once you upload your code onto the board, where does it store it? It stores it in the flash memory. That's where it goes first. Write your code, upload it, and then the first point of contact where your code is stored is the flash memory. Understood? Now, for the SRAM, once there's no power connected to it, the SRAM loses its data. So once you write your code, you upload, and then it stores it in the flash. And then once your code is running on your board, right? What it does is that there is some data that it generates, right? It stores that data within the SRAM. Understood? So now, if I write a code that does, for instance, if I have a code that int A is equal to 5, right? B is equal to probably 10, and C. So I have a variable A, B, and C, right? And then I say C is equal to A plus B, right? If I write this code and I compile it and I download the code onto my board, onto the flash, right? Once it is running, right, you can see that there is data here. A is equal to 5. Where will it store the A? The A is equal to 5 is going to be stored in the flash. Sorry, in the SRAM, right? The B is equal to 10 value will also be stored in the SRAM. So these are values that are generated when the code is running. So it will have to go and read the SRAM values, the 5 and 10, and then come and add them together. So that's what this program does. When it's running, it generates some data. Those data are stored in the SRAM. Understood? So we are getting the difference between the SRAM and then the flash, right? Right? Do you guys understand? I mean, then there is EEPROM. You can go and study more about it, but we don't have that much time. So the generic architecture of the Arduino is that we have CPU, we have some forms of memories, and then we have peripherals, some attachment to the microcontroller. Understood? And then this, as I said, we can also interface and kind of sensors and stuff with the microcontroller. And then specifically on this board, on this Arduino board, right, we have sensors like the pressure sensor, we have temperature sensor, we have switches, we have probably okay, then we have person in room sensor, right? It can sense a person within a room, within this room, right? So it has so many sensors that we can interface with the board. And then this one also has Bluetooth. The other one, the Arduino Uno, has no Bluetooth. If you want to connect a Bluetooth to it, you must buy what is called the shield and connect the Bluetooth to the shield before you can connect it to the board. But this one has an internal Bluetooth that you can use. Understood? Any questions so far? Nothing. Right. So now there are clear differences between the Arduino Uno, right? And then the Arduino Nano. I said, this is what? Huh? Yeah. This is the Arduino Nano, right? So there are some clear differences between them. Now the chip, the CPU that the Uno uses is the Atmega 384P, but the chip that the Nano uses is the NRF 52840, right? And then the operating clock frequency is 60 megahertz for the Uno and 64 megahertz for the Nano. So in terms of operating frequency, which one is better? Hmm? Why? It has a what? A wider range. What do you understand by frequency? The frequency of your computer, or like generally, what do you understand by frequency? Huh? Do you know the formula for it? You guys have never heard frequency before? Huh? Frequency is equals to what? 1 over what? What is T? Period. Yeah. And then it is measured in seconds, so it's time. But we have your frequency is equals to 1 over, yeah, the period. We say the period. Understood? So here, if I have 64 megahertz, right? What does it mean? It means that the time that it will take to run a program within 1 second, right? So frequency is just frequency is just the cycles, the number of cycles a program takes to run over frequency is equal to the cycles per second. The number of operations, the number of data, or the number of work it can do within a second, right? So if you have 60 megahertz, so it means that it can do more within a second. If you have 64 megahertz, it can do more within a second than the 60 megahertz, right? Now for the flash memory that I talked about, the Arduino Uno has 32 KB. What is KB? Kilobyte of data, right? While the flash has what? 1 megabyte. So you see that the flash can actually store more of your code than the Uno, right? That is why this board can be used to run machine learning algorithms, but the Uno cannot be used to run machine learning algorithms because this one has more flash than the Uno, right? Now, one important thing is that the I/O voltage, the voltage that you can supply to the board. If you check the if we check the Uno, it takes 5 volts, right? But the Nano takes 3.3 volts. Now, if you supply this board with a 5 volt, if you supply it with 5 volts, you might end up damaging it. You just spoil it at once. So you need to be careful when supplying power to this board, right? Understood? Now, for the pinout, right? For the pinout, we have the Arduino Nano has 14 digital pins, and then it has 4 analog pins. You guys know what digital means, or digital pins are. Now you know what analog pins are, right? What is a digital pin? If I say this pin is digital, Masa. Digital, and so you guys don't know what digital and analog means. But you guys are telecom engineers. Masa. You know digital signals and then you know analog signals, right? Yeah? Manually. Yeah. Probably close, yeah, but no. Digital analog, digital analog, digital. You guys are doing signals and systems, right? Then the first thing you study is like the difference between a digital signal and an analog signal. Yeah, the analog signals are from the environment, like they sense from the environment. And then you see that once you sense from the environment, the range of values is so huge, right? For instance, if you are sensing temperature, right, it can be 32 point something, this point, it can be a range of values, right? So, but digital values are, we scale the value down to zeros and ones. Do you understand? Okay, but that is not the course for this one, so you guys can learn it somewhere else, right? Now, as I said, for the Arduino Uno, right? If you want to use a Bluetooth, you have to connect it via a shield. But the Arduino Nano has an embedded Bluetooth 5.0 embedded on it, right? So you don't have to connect anything to it. You just have to learn how to use it on the board, and then you'll be fine, right? And then the weight, you know that the Uno is far bigger, so it will weigh more than the Nano, right? It's the Uno is 25 grams, while the Uno, this small thing, is just 5 grams, right? So now you have to, once you are designing an application, or you are probably most of you will be using one of these boards, the Uno or the Nano, for your final year project, right? Has any of you thought about your final year project? Hmm? Pardon? Are you studying your final year project? Ah, wow. Eh? For the uh, for the diploma, what does that mean? Ah, you guys did the diploma course, and then you are doing. Ah, I didn't know that. But you guys finished an entire project within the diploma course, right? Aha. But you guys are done with the diploma without a project work.
We did.
Huh?
We did the project, but we are left with the presentation.
Ah. Okay. So it means that you do a diploma, you do a project, and then for this one too, will you guys do another project, or you continue with that project today?
Another one.
So what did you guys use for the project? What what tools did you use? Huh? But only you guys said only one person has an Arduino board here. So how did you use an Arduino? And then they accepted simulations as final year projects. Cool. Yeah. But the point is that uh, probably a lot of you will be using the Arduino board for your projects, right? So that's why I'm trying to go through this one so that it makes it easier for you, because the learning curve is quite, once you are new to it and then you enter into 4V and then you are now going to learn how to use the Arduino board, then you begin to panic, and then because there's no enough time, right? But you need to use it for something. So that's why within this third year, I want you to learn how to use it so that it becomes just easier for you to program it when you are doing your final year projects, right? Understood? Also, so this is the part of the Arduino Nano sense, right? This is it. And then, as I said, it has 8 analog pins. The analog pins take signals from the real world, and then those signals are in the form of waves, right? You guys know what this wave is, right? You know what this wave is, right? So those waves, where is it? So those waves are analog, and then we have digital waves are like this, right? Just ones and zeros, right? So there are clear differences between an analog signal and a digital signal. So here we have 8 analog pins here, and then the 8 analog pins can provide a 12-bit ADC at 30 kilohertz. Who understands that statement? 12-bit ADC at 30 kilohertz. You guys are telecom engineers. This is just a basics of telecom engineering, right? Or 12-bit ADC at 30 kilohertz. Telecom. What does an ADC mean? Master Hana. Yeah. So and because these are, you see, the issue is that the CPU, the CPU within the Arduino boards are kind of digital in nature. They accept digital signals. They accept signals that are discrete, that are ones and zeros, that are in that form, right? But once you bring an analog signal to the CPU here, it doesn't understand analog signals. So you need to convert those analog signals to what? To digital signals. So you use an ADC to convert those, to convert from analog to digital. So you guys know what an ADC is, analog to digital converter. And then we say that the analog to digital converter is 12 bits. What does that mean? So what is the least value it can take? So it means that the 12 bit is the range of the ADC, right? So it is sensing data from the environment. So, but what, like, we need to have a minimum number and then a maximum number it can go, right? So the 12 bits just means that it can, the highest value it can take is 2 to the power 12 minus 1. It can take values from 0 to 2 to the power, 2 to the power 12 minus 1. Do you guys understand this? Do you understand it? I think you guys have already done it in signal to system or whatever course it is. You guys will do it. Right? So it means that we can take what is 2 to the power 12. Eh? What is 2 to the power 12? What is 2 to the power 12? Hurry up, hurry up. This is just basic math. Eh? 144. Master. 2 to the power 12. Anybody? Please hurry up, hurry up. You guys have laptops or you just come in and let's see the range. 4096. These are terms or these are calculations you must know of it. What is 2 to the power 10? What is 2 to the power 5? These are basic things. So you must learn like number systems, like decimal numbers, binary numbers, and stuff like that. You must know this of, of it, right? So it means that it can take a value 4095 is 2 to the power 2 minus 1. Right? So we can take values from 0 to 4095. Right? So a long range of values. You can read a long range of values for the analog. Right? And then it samples at 30 kilohertz. What does that mean? These are telecom terms I'm using. I'm not even a telecom engineer. You, you guys are telecom engineers. You guys did a whole diploma on telecom stuff, right? Very good. So if I say we are sampling as 30 kilohertz, what does that mean? Hmm? The space or the speed?
No, it should be it should be the space, not the speed.
The space.
It should be the
As I
space.
said, if we take a digital signal like this, an analog signal like this, right? Something like this, right? And I say that we are sampling as 30 kilohertz, right? So we have a period that it takes data from the analog signals. it picks it picks a sample from here, sample from here, sample from here, sample from here. It picks the points. It is sampling. It is picking the points within the analog signal, right? It's picking the point. Then it can pick 30,000 samples. 30,000 of these points, right? So we sample like 30, uh, 30 kilohertz means that 30,000 samples within a second. Understood? You understand? So we are picking 30,000 points within the analog signal at a second. So probably you guys will say that the sampling rate and all those, all those stuff. I think, and I also learned them back in tech, but a long time ago, like 2009 or 2010 there. Yeah, 2010 or 2011, one of them. Long time ago, but and I still remember it from. But you guys studied the diploma just how many years? So we just always try to. There are some terms within engineering that you can never forget. Once you forget them, it means that you have lost your engineering degree, master. Right. So we have eight analog. We have eight analog pins within here. So the analog pins serve as inputs. So once we connect an analog sensor to it, it serves as an input to the board. But as I said, the CPU cannot read analog signals, so it has to. We have to convert it into digital signal using the ADC. So the ADC will convert it for us. So all the analog pins are connected to an ADC, right? And then we have integrated sensors, the IMU, inertial motion unit. It has a microphone on it. It has the light sensor, pressure, temperature, humidity. And then it also has digital pins, right? So we have analog pins, we have digital pins. Now the digital pins serve as outputs. So understand, analog pins serve as what? Inputs. The digital pins serve as what? Outputs. So you can give a signal to the digital pins, right? You can send, and then as I said, for the digital pins, they take 1 or 0. A digital pin is either off or on. But 1 or 0 means that there's voltage applied to it. A 0 means there's no voltage applied to it. 5 volts or 3.3 volts means that I've applied voltage to the pin. So if I want to send some signal to the digital pin, in my code, I have to just write that this set this digital pin, and then I give the pin number to high, and then it will send some 5 for here 3.3 volts to that pin, right? If I say set the digital pin to low, it means that there's no voltage applied to it, right? So if I set it high and then I connect an LED to it, right, the LED will light up. If I set it to low, I connect an LED, the LED does what? Huh? It will be off, right? Now, so it means that the digital pin is either on or off. 5 volts, 3.3 volts, or 0 volts, right? And then that is how, and then the only way to know whether it's on or off is when I connect an LED to it, right? So now there's another important parameter here. The digital pins all have what is called the PWM. Who knows what the PWM is? Another telecom term. I'm not a telecom engineer, but PWM. You've never heard it before in your entire life. So if I have a digital signal, yeah. But you guys know the terms, but anytime I ask for it, you guys behave as if you have never you have never seen it in your entire life before. Abba! Huh? Pardon? So how do you say it? The entire way? So it's pause with modulation, right? This is how it looks like. So this is a digital signal, right? A digital signal can be either high, right? A high means what? One. Or it means that I've applied 3.3 volts to it based on the board we're using. And then a low means what? Zero. Or 0 volts. So this is high. And then it comes low. Then it goes high. It goes low. Right? Now, if I connect an LED, right? If I connect an LED to any of the digital pins, it is either high or low, on or off. Right? Now, if I want if I if I want the LED to dim, how do I do it? Huh? So I have an LED, right? I want it. It is either on or off. So if I want it to dim, right? Logically, what do I do? I reduce the voltage. So from 3.3 to probably 2 point something, right? But but as I said, the digital pins only take a 1 and a 0. Understood? A digital pin can only be on or off. It can't take 2.2 volts. Are you listening? It is not an analog pin. An analog pin can take, as I said, a range of values from 0 to 4096. It can take a range. But the digital pins take only 1 or 0. It's either high or low. So how do I dim it? If I reduce the voltage, it won't work because it's a digital pin. How do I dim it? Huh? What? What is medium? What is what does medium mean? A high is 0 or 0 volts. A high is 3.3 volts or 1, logic 1. A low is 0 volts, right? So now I want to dim it. I don't want it to be so bright, but I want to dim it. What do I do? As I said, it's a digital pin, and I just took my time to explain it. It's a digital pin. The digital pins only take 3.3 volts or 0 volts. It can't take half. It's not an analog pin. So how do I do that? Huh? Yeah, so that's what we do. We use the pulse width modulation. So this is 1 or 0, right? So if I want to dim it, right? Right? In case I want to dim my LED, what do I do? I put it on, right? Then I put it off for a short amount of time and put it on again and put it off for a short amount of time. So the off for that short amount of time, your eyes will deceive you as if it has dimmed, but it actually goes completely off and on. But it is doing it so fast that your eyes deceive you as if it has dimmed. Understood? But it's actually going on and off so fast, so fast. Understood? So this is one technique to dim the LED using the digital pin. But if it was an analog pin, I can just reduce the voltage and then it will dim. Understood? These are all telecom terms. Yeah, yeah. But again, the analog pins are what? I said it. The analog pins are what? Input or output?
They are input.
The analog pins.
Input.
So you see that the LED, once you connect the LED serves as an output. The analog pins are taking a signal and giving it to the microprocessor. So you don't connect the LED to the analog pins, just the digital pins. Understood? So this is the pin mapping of this Arduino sense, the Arduino Nano 33 BLE, right? You guys are engineers. You guys can understand what this architecture means, right? You guys are Master. Anytime you guys see something, you guys behave as if you are like. So as an engineer, you must understand a diagram like this. Once we say diagram like this, it's just the pins and then the names of the pins, right? As I said, we have analog pins, we have digital pins. So here, if you see A0 to A7. These are analog pins. I said the analog, there are 8 analog pins, right?
Yes.
So A0 to A7 are just the analog pins. And then within your code, in case you are writing your code, right? This is the name. If I want to use the analog pin, I must use A0 to A7, any of them. So in your code, I'll write A0, A1, A2 to A7 if I want to use the analog pins, right? For the digital pins, you can see that they are from D2 up to probably D12 or something, right? So these are the digital pins. And then in my code, if I want to refer to a digital, if I want to refer to a digital pin, I must use D, then the number. If I use D2, it means I'm referring to this P. If I use D6, I'm referring to this P, right? Or I just write a number. Only the number two will do. I can just use 6, 2, 3, and then the board knows that I'm referring to the digital pin. But in the analog pin, I must always use A something, A something. But for the digital pins, I can use D something or just the number. Understood? So, and then on the board too, normally we have the ground. So you can see we have ground, like 2 grounds here. We have 5 volts here. We have 8.3 volts here. So, and then we have the voltage here. We have RxTS, receiver transmitter, right? Easy, right? And then we have the built-in LED. The built-in LED is over here. This one. And then it's connected to digital pin D12. Have you seen it over there? Have you seen the D13 over there? It's
Yes.
connected to the built-in LED, the built-in LED here. I think the last time we did a test where I blinked this, right? So that was the built-in LED. Understood? Chema? Yeah? Understood? Shall I continue? Any question here? So now the sensors or all the components within the thing also have pins, right? So and then the pins are over there. You can actually go through it in your free time. But now, an important thing is that this Arduino Nano Sense, the Arduino Nano, there are so many versions of it, right? We have the Arduino Nano, just the word Arduino Nano, that's just the name. Then we have the Arduino Nano Every. We have the Arduino Nano 33 IoT. We have the Arduino Nano 33 BLE, and then we have the Arduino Nano 33 BLE Sense. So this is the Arduino Nano 33 BLE Sense. And then, so you must be careful when you are buying your Arduino boards. You must know exactly what you are doing, what your application is doing, what you are going to build. Because some have some components, some do have some components, right? So if you go and buy the wrong one, probably it won't, you can't use it for your project or whatever. So you must know exactly which Arduino board or what your application is doing, and then you choose the exact board that can implement what you are doing, right? For instance, for the last one, you see that we have the Arduino Nano 33 cents and then the Arduino Nano 33 BLE. Almost the same. The only difference is that we have to check here. The Arduino Nano 33 BLE sense has a number of sensors integrated on it, but the Arduino Nano 33 BLE has no sensor. So it means that if you must connect a temperature sensor, you must buy a temperature sensor. But if you want an application where the temperature sensor is embedded on the board, you need to use the 33 BLE sense. Understood? So you must know the kind of board you want to use. Right? Now this is the power, we call it the power tree of the 33 BLE sense, right? It takes, you know that when I was uploading the code, I connected my board to the PC, right, using this cable, right? So it picks the voltage from the USB, as it can be seen over there, right? And then it uses a diode. What is a diode? Diode. Eh? Electrical engineering. Who did
It doesn't allow the power to pass through.
you did electrical engineering somewhere, right?
Yeah.
Who did electrical engineering somewhere? Who? Masa. Who did electrical engineering? Nobody did electrical engineering anyway. So nobody knows what a diode is in one direction. Ah, but you guys know all these things, but you guys make people to get something for nothing. Allows current to flow in one direction. So it has a diode and then it has a DC to DC converter. And then the Arduino, the CPU takes some kind of current, right? It takes a specific current, and then the current cannot go above some level. The sensors also take some specific current, and then the user application, what the code you write, right, also takes some kind of current, right? So all of this, the 15 milliamps, 2 milliamps, 950 milliamps are the maximum that it can take. It can't go above that. Goes above that, it damages that component. Understood? So the CPU, as I said, on the Arduino 33 BLE sense is the NRF 52840, right? And then this CPU is based on what is called the Cortex M4 processor, produced by ARM. You guys know the ARM, the company. You guys know ARM, ARM. You never heard of that one before. Hey, you never heard of ARM before. You never seen this word before. ARM. They produce CPUs. Probably all the CPUs you've seen are produced by them. And then this one is the Cortex M4 processor. And then it has a single precision floating point unit. What is a floating point unit? Floating point unit. Hey, what's that? So if I take a typical CPU, right, what does it contain? Within the CPU, within a CPU, just the CPU, it has control units, right? It has what is called the ALE. You guys will know this already. And then sometimes it has memory. Sometimes it doesn't. Sometimes it does. Right? Now, what is the purpose of this? What is the purpose of this ALE? So it performs arithmetic and logic operations. So normally, if we take a typical CPU, right, you can perform operations like what? Addition, right? Subtraction. You can perform an AND operation. You guys know what an AND operation is? An OR operation, XOR operation, right? It can perform all of this. And then what the CPU does is that I think that the last time I said the CPU fetches instructions from memory, right? Then it does what? It decodes the instruction, right? Then it executes the instruction, right? Then it writes back to memory. You guys know this already. The CPU it fetches instruction, decode, executes, and then do memory write back, right? So and then it goes through the cycle again. Fetch instruction, decode. But what is important is that it can only do one operation at a time, right? So it can only do an addition, so it can only fetch an addition at a time, or a subtraction, or an AND at a time, or an or an XOR. Understood? Now, if I want to do an operation like 3.1 plus 3, how do I do this? How do I do this operation in your mind? Like as a human being, how will you solve this? Hmm? This plus this one too. Now, so you might you so how do I add decimal? So if I'm adding numbers like 1 plus 2, there's no decimal, right? You just add this one. 1 plus 2 is what? 3. The CPU can just do that in one cycle, but it's gone. Now, if I'm adding 3.123 and 32.324.1, these are these are what is known as what? Floating points. Because there's a point. It's a floating point number. This is a decimal number, just a decimal number, an integer. Just integer. This is a floating point number. So how does it perform? How do you perform addition using floating point numbers? Hmm? Uh-huh. Hurry up, hurry up, hurry up. Yeah, yeah. For 5 marks. I are there. Hmm? What? And then I'll subtract 2 marks. Yeah. Yeah. So, so now, so how, so you must be thinking, you see that once I give it to you, you just did it without even thinking, right? But it follows some algorithm, right? The decimal points must be together. In case you are trying to add decimal points, right? Numbers with decimal points. The decimal point must be what? In line, right? So it means that if I have something like this, well, 3 point this, and then I have 3 2 this point this, I have to shift the number. Now the ALU can shift a number, shift right and then shift left. The ALU can do that, right? So it means that if I'm adding normal integers like just this one, as I said, the CPU does one operation at a time, right? So it can just go here and just pick this equation and just do it. But if I'm doing addition that has floating points, it means that the CPU must first shift one of the numbers. So it must first of all shift right or shift left the number, just one operation, and then go back to do, and then come back and now do the addition itself. So it takes a lot of time. So what they do is that they build special units called the floating point unit that will do that for us in one cycle, right? So the floating point unit is always outside the CPU, right? So now you have the control units, ALU, memory, and then you have an FPU, floating point unit, so that anytime it sees floating point numbers, it sends those numbers to this unit so that it can compute those numbers faster. Other than once you are using the ALU to do this kind of computation, it takes a lot of time, right? So that is what the floating point unit is. So this board has the Cortex M4 processor with a floating point unit. So it means that it does decimal calculations very, very fast. Understood? So it has 1 MB flash and stuff like that. Now, there's a very, very important thing here about the flash, right? The flash weakens anytime you program it. So anytime you are programming a flash, it has some kind of a life cycle, right? You can't always program it all the time. It gets weak. Once you program it once, it gets weak. You program it for another one. The lifespan comes down, right? So you can actually program the flash within this board 10,000 times. So if you are running, if you are coding on your on board, and then every time you are uploading codes, once it get past 10,000 times, then you know that you are in trouble. Your board, the flash might not work again. So it means that you cannot upload codes on it anymore. So so anytime you are uploading a code, you need to be sure that it works, so that you will just run the code once. If not, once you are uploading the code all the time, you must know that the life cycle of the flash is also going down. Right? So don't go and buy a board and just upload codes. So it means that this one, if I run codes, if I upload codes 100 times a day, how long will it take to last? Just easy maths. You can, I have 10,000 times I can upload codes, right? And then I upload 100 codes a day. I upload 100 codes a day. How long does it take before the flash gets damaged or it gets degraded? 100 years. All right, that's fine. Now, the flash is also divided. Let me not even go here. What is the time? What time do you close? Okay, so, huh? Car from where? To Medina. Okay, so I think so. I think I showed you how the Arduino code looks like. I said the code in Arduino is called the what? Oh, Masa. And Arduino code is called what? Ha! Nobody. Huh? What? I can't hear you. Error. No, no, no. And Arduino code is called what? Hurry up, hurry up, hurry up, hurry up. A sketch. And then, as I said, the sketch has two main functions within it. What, what, what is the first one? And then what is the second one? So it has the setup function and then the loop function, right? And then I said, what does the setup do? I said this the last time, so pardon? Yeah, it will initialize every value within it, right? Then what does the loop do? So it runs the code, it loops the code like loop is an English word, so you, you should understand what the loop is. Now, yeah, once you have the as I said, the Arduino deals with just libraries, right? So that's why it makes it very easy to use. Based on the library, once you know what library to use, it becomes so easy. If you don't know the library to use, that's where it becomes tricky for you. But you must know the library to use. So the Arduino deal with libraries. So in the setup function, the Arduino calls some kind of setup libraries. And then in the loop function is what you are writing. So you can define the functions within the loop for it. Or you can define a function outside the loop and then outside even a sketch. You can write one sketch, right? And then you can call that sketch within another sketch of yours. You guys know how that works, right? In C programming and stuff like that, right? So this is how it works. We have the setup and then we have the loop. It's as basic as that. So let's just do let's just do one code and then we go away. So so this is an example of an Arduino sketch or code, right? What do you think this code is doing? Let's hurry things up. Huh? Okay, okay. Let let's start. We have the setup and then we have the order. Look, the first line in the setup, put your code. What does that mean? Sir? Doesn't run. The first line after the setup. What is it called? It's a comment, so it doesn't run anything. So means that we go to the second line. Serial dot begin. What does it do? So you must understand what your code is doing, right? And then as I said, it's just libraries you are calling. So the serial is a library, and then the dot begin is a function within the library. So if you see a code like serial dots or something dot something, it means that we have the first word is the library, the second word is a function within the library that is calling, right? The serial dot begin 960. Have you guys ever seen this thing anywhere before? Those of you those of you who did the diploma and then you use Arduinos and stuff like that. You guys have never even seen this info. Then what program did you write? Or you guys just saw the program somewhere they just kept it together, they don't know what it even does, but it just works. Huh? So once it's working, you don't have to know how it works. So serial dot begin, right? Now the I showed you. Let me see. I think I showed you something. I showed you the and I even showed you the interface of the Arduino IDE, right? So Arduino recording. So we have to repeat everything again. Oh no. Okay. So now, what was I saying, sir? So the digital write means that I want to write to the pin that I set, right? So if I say digital write 30, I'm referring to the pin, and then if I give it a high, it means what? Huh? On. If I give it, then I come. You see that everything here is a library. Delay is another library, right? And then I think I explained the delay library the last time, right? So we have the delay library, and then the delay library takes a value. The value within there is in milliseconds. I explained. So if I write delay into brackets 5,000, what does that mean? 5 seconds. So because the 5,000 is in milliseconds, the delay takes milliseconds values. Right? After that, I do digital write 13 low. What does that mean? Oh, then I do the delay again, 5,000 again. So it means that I off it for how long? 5 seconds. Then I do serial print. Now here, if I use, as I said, Everything is a library, and then the dot is a function within a library. So if I do serial dot print, so you mean within the first line of code, you see the line up there on sign and counter is equal to 0. I've set a counter value to 0. Then I want to print that counter value. I do serial dot print here counter. What does that mean? Anybody? Those who have used the Arduino before and those who did simulation with it. So this counter value is from the company. Have you seen it? It starts from 0. Are you seeing it? It's set to 0 on the top here. So if I come here and I say serial dot print counter, 0, what does it print here? Hurry up, hurry up, hurry up, hurry up. Pardon? It prints a what? Okay, so the serial dot print, the counter value. So the first counter value is what? 0. The comma 2 means what? Serial dot print counter comma 2. What does that mean? Oh, no. So so you see that numbers can be represented as integers, right? We have, okay, you guys have learned the base of numbers before. Base 2, base 8, base 10. Eh?
Said I remember something like that.
Eh?
Said I remember something like that. I check.
So we have binary numbers. Binary numbers are made up of only zeros and ones, 0, 1, 0, 1, 0, 1, 0, 1, and then it means something. We have decimal numbers, right? We have hexadecimal numbers. So if I do something like serial print counter comma 2, it means that the number I'm printing must be binary, 0 or 1. So if the number is 0, it will just print a 0. If the number is a 1, it will print a what? If the number is a 2, it prints what? Eh?
Zero.
It prints what?
Zero.
So it prints, if the number is a 2, it prints 0. Eh? If the number is a 2, what does it print on the screen? I said we are with the 2, we are printing only decimal numbers. 0, 1. 0, 1 is equal to 1. 1, 0, yeah. So we go and learn these number systems. It's very important. So if it's a 3, it prints a what? 101 is 5. 1, 1 is 3. Understood? A 4 is what? 0, 1, 1 is still 1. 0, 1, 1 is 3. 0, 1, 1, 1 is 7. Hurry up, hurry up, hurry up. If I want to print a 4, 0, 1, 0, 1 is what? 5. Eh? 1, 1, probably 8 or something. Eh? What, I got 0, 1, 0, 0 is 4. These are just easy stuff, right? So here, this just means that we are printing decimal numbers. And then I do serial dot print. There's a space here. What does it mean? I'm just printing a space. So I print, let's say the number is 4, right? So it will print 1, 0, 0, then space, right? Then it comes here, another serial dot print counter comma system. What does the system here means? Number system, hexadecimal. So the hexadecimal of 100 is 100 is what? Number systems. So hexadecimal numbers ranges from 0 to F. 0 to F. and then there are always 4 bits, right? You take the 4 bits and then you convert it to 0 to F, right? So if I have something like 0000 is it has a decimal is what? 0, right? Listen. Now if I have 1111, 4 bit number, in is a decimal is what? F. 15 in decimal. 15 in decimal. So you must learn how to convert decimal numbers to hexadecimal to decimal, stuff like that. Right? So now if I have 100 is 4, right? So it just in a decimal, it just 4. Understood? And then after that, I do serial dot break, another space. Yeah, the space here, and then I do serial dot break from line 50, 940 to 6. We print on the same line. Yeah. So now, listing this print, once I do serial dot print again, it's just printing on the same line. Now, if I want to print on a different line, what do I do? Serial dot print line, ln serial dot. So everything's just library. So serial dot print ln will print the number in the next line, or it will print and then move to the next line. But if you do serial dot print, it prints everything within one line. Understood? Do we understand? Now, this. So this code here, the counter is supposed to be counter plus plus. It's supposed to counter plus plus. You guys have coded in C plus plus, right? You guys know what counter plus plus means. If I write it like counter plus plus, it's just the same as counter is equals to counter plus one. Understood? So if I put here counter plus means increment the counter. So now if you increment this counter from 0 to what? 1. And then it goes over the code again. That's everything. I can increment the counter from what? 1 to 2. So it goes 0, 1, 2, 3, 4, going. So if the loop keeps running, the counter will increase value from 0, 1, 2, and then in a serial print, it's printed that counter from counter to 2. Once the counter value what? The counter is at 0 right now. Yeah. The loop will keep running. So the serial print will reach from 0 to 2. Like it will print from 0 and 2. 0 into, I don't understand. The counter is 0 right now. Yeah, it goes. Then if I get here, I say here it's counter plus plus. If I get to counter plus plus, it will go to 2. But it won't print it. No, wait, it will print it, counter plus plus. So it will print the incremented value. We are printing the incremented value, right? So 0 to 1. And then it goes and repeats everything again. Digital dot right. So it will turn on the LED, delay it, turn it off, come and print that counter value that it's incremented, right? Then in binary, print it in decimal, and come and increment it again. So now instead of it being 0, it will be 1 plus 1. So it will increment to 2, then it goes again. Come and do everything, increment to 3, 4, 5, then going, right? So you can just, I can just run it. Let me just run it and then we go away. So yes, counter plus plus, save it. So you see that I cannot run my code without selecting the board. So I have to select the board here, but it's not connected. I have to first of all connect it, right? So I connect the board, and then you see that once I connect the board, you can see that it has come here, Arduino Nano Sense, and then it shows you the COM port is connected to it's COM9, right? Select it, and then I just run it. So any question so far? This is the last thing we are doing. So anything from the beginning, anything. You guys understood every single thing, right? Huh? So it has finished running, and then I just upload. And then I check my serial monitor after it has uploaded and see how it is running in my code. Right, it's done uploading. So you can see that it is blinking, right? It blinks and then it prints a number. So it starts from what 000, and then it goes what 100, what 22 or something like that. Then it will just be printing those binary, then hexadecimal numbers for me, right? Understood? So you guys can go and try it at home. But you guys were supposed to do some assignment. I had to finish everything, and you guys were supposed to do so the page, the GitHub page that I created, I post everything there. So I posted an assignment, but because I've not done it, so probably next week. So go and take a look at it on your own and see whether you can do it, and then run the other course. If you have an Arduino board, any board can do, but you have to download the libraries for that board, not this one. So if you have the Uno, those who have the Uno, just go and run the examples before next week, right? Right. So that's all for today.